Area involving inscribed figures. If you ever plan to take calculus, sometimes calculus is called analytical geometry. There's quite a bit of geometry involved. There's one-dimensional geometry, there's two-dimensional geometry, there's three-dimensional geometry, and you could try to guess what the fourth-dimensional geometry is. In this example, this is actually 2 dimensions, and this is a very, very important concept. What you want to see here is the total area. The total area that we're interested in is the shaded part. So it's really the area of a semicircle minus the area of a triangle. So with geometry, a lot of times you have to take things apart. And that is really what the intention here is. You want to be able to take things apart. So we have the large area, which is the semicircle, and then you want to subtract the smaller area, which is this isosceles triangle. And then, of course, what's left over, the leftover part is these little tiny pieces that look like pie crust. There you go. So you have those 2 little pieces there. Why don't we label the expressions for area? So let's say the area of a semicircle. It's pi r squared divided by 2. And then we want to subtract the area of the triangle, which is 1/2 the base of the triangle times the height of the triangle. We could actually see that in the picture. We know that from here to here, this is 9 millimeters. This is 9 millimeters. And then the height is also what? 9 millimeters. The radius of the circle is clearly given. So why don't we simplify this expression? We do have common denominator. And now we're ready to substitute. So pi, r is what? R is 9, square it, minus, the base is 18, and then we also have a height of 9, all divided by 2. There is a greatest common factor in the numerator. That greatest common factor is 81. Let's see what's left. Pi squared, parentheses, pi squared minus 2. Yeah, all divided by 2. All right. This is sometimes what we call an exact answer. We got to include the units, so it's going to be square millimeters. So there's the exact answer. I am going to circle that. Even though we're asked to find the decimal answer, you in algebra or in much of mathematics, you want to find the exact answer. The exact answer is often necessary to find the decimal answer. Now, we're ready to find the decimal answer as well. We're going to substitute pi. Instead of writing pi, it says to use what? It says to use 3 14/100 as an approximation. And we could do that on your calculator. Make sure you do the order of operations. And you should get 81 times 7 8 5 9 6, and then divide it by 2. Let's see what that expression looks like. You get this number here, 318 decimal 3138. And once again, make sure you put the units. In this case, square millimeters, and then circle your answer. Another problem involving analytical geometry. This geometry happens to be in 3 dimensions, and we're talking about volume. So that's going to be very important when you're going to label your units. Let's read the problem. The radius of a cylindrical construction pipe is 3 feet. If the pipe is 29 feet long, what is its volume? So you may have seen pipes. Sometimes you see them on the trailers of moving trucks on the freeway. A lot of these pipes, if it's this big, it probably could be conveying a gas line, or it could be a water line, or a water main, or a gas main. So these are pretty big pipes. When you have a pipe that's has a radius of 3 feet, that diameter is 6 feet. So very likely you could probably stand into that pipe. You could imagine how big that is. Of course, that's assuming you're not 6 feet tall. All right, our goal is to find the volume. First thing you want to do is, if you haven't already, make sure you have a formula sheet for this class. Write it in front of your homework. Pi r squared times h is the volume of a cylinder. Typically, a good way to remember it is you have the base here, and then you give it some height. So you take the base, you shade it, looks like a little disc, and then you just give it height. And then that adds the third dimension. Height is the third dimension there. And so we're talking about volume. Let's substitute everything. And we'll go ahead and find the exact answer as well. Volume is equal to pi r squared times h. And we're going to have pi. We're going to have r squared. R is 3. And we square it. And then we have multiplied by 29. So what's 29 times 9? So it's 270 take off 9. It should be 261, but I'm going to double check. 29 times 9. It is 261. So this is 261 times pi. Now what are the units? The units is actually cubic feet. And the way we write that is FT and then superscript 3. I am going to circle this, even though it's not the final answer. It is an exact answer. It's very important in algebra. We need the exact answer before we could actually get the decimal answer. Let's try to find the rounded answer that it asked for, 261. We're going to substitute 3 and 1400ths. And then those units, of course, are going to be in cubic feet. Do that quickly on your calculator. And we get 819.54. And once again, make sure you put your units. Always write your units on your sheet of paper. There you go. That is the final answer. Oh, I take that back. That is not the final answer. If I read this, it says round your answer to the nearest whole number. Not a problem. This one here, that is a what? That's a 5. So 5 or more, we actually round up. So we got to round up to what number? Not 819, but we're going to round up to 820. There we go. Let's fix that a little bit. Here's an 8 here. That was a 5, and this was a 4. Hang on, let me fix something. I want to be neater here. Try to be neater here. Let me try to fix this right there. That needs to be raised so I can see an 8. That should be better. Okay. Let me erase this as well. It says round to the nearest whole number. Not a problem. 820, and then cubic feet. Now circle the answer. Another analytical geometry problem. This time we're looking at volume. So volume automatically is 3 dimensions. You can even look at the picture. That is a 3-dimensional picture. If you haven't already, make sure you create your own formula sheet. Put it in the front of your homework or your homework binder or your homework notebook. It might even go over more than one page, but keep a formula sheet where you could find all the formulas that you encounter in this course. There is the formula for the volume of a cone. 1/3 pi r squared times h. Well, we can see the h. H is actually 10. And the 11 here is the diameter. So r is going to be 5.5. And we're going to write r to be 11 halves. How about that? And we're going to find the exact volume in terms of pi, the exact answer. So exact answer, which means we're going to leave the answer in terms of pi. Very, very important computation in algebra. Exact answers are great. All right, let's substitute. V is our expression. We're going to take 1/3 pi. R is actually 11 halves. We're going to take that, square it, and then we're going to multiply by height, which is 10. So we got 121 times 10 all over, let's see, 12. Oh, did I forget a pi? Here, there's the pi. Let's simplify that a little bit more. That's 1210 over 12 times pi. You could certainly simplify that even more. I guess we could divide by, try 2. 2, so we have 605. I take that back. No, that's right, 605. 605 would do it, and then over 2, which would be 6. Yeah. Times pi. There we go. We just need exact answers. I'm pretty sure that's reduced. Yeah, 2 doesn't go in there. 3 doesn't go into 605. How do I know that? 6 plus 0 plus 5 is equal to 11, and 11 is not divisible by 3, so I know 3 doesn't go into 605. So I know this answer is reduced. Now all you got to remember is put your units. Unit of measurement is very, very important for all STEM majors. Make sure you label things with the appropriate units. Let's graph this rational function. H of x is equal to 2x minus 8 over x squared minus 6x plus 8. Let's see. First thing, instinctively, you want to check the numerator and denominator and see if it factors. See if there's any greatest common factors. The numerator has a greatest common factor of 2. The denominator has factors. Let's just say that. Let's react to that. X minus 4 and then x minus 2. And I checked it. Those are correct factors. Now, these are factors. Now, what happens here? Keep in mind, we should be paying attention to the domain right now. So the domain says x cannot be 4 and x cannot be 2, right? We can't have 0 in the denominators. Now, what does h of x look like? Well, h of x, h of x looks like g of x. I'm going to give it a new name. G of x is equal to what? 2 over x minus 2 with a location of a whole for this ordered pair, with a location of a whole. How about I say this? Let me rephrase that. With the location of 4, 1. Yeah, 4, 1, with a location of 4, 1 being a whole. All right, we're ready to graph this. So our goal is to graph h of x. H of x looks like g of x with a whole. let's get some graph paper ready. All right. Let's graph the vertical asymptote. Vertical asymptote is located at x equals 2. Right here it's indicated x equals 2. There it is. The vertical asymptote is x equals 2. 1, 2. And let's draw. And we need some ordered pairs. So why don't we get some ordered pairs for who? Let's do x and g of x. Yeah. Let's do 3. And then we got 2. And what else do we got here? We also need to pick, let's say 1. And we have negative 2. Okay. That should be pretty good. We have 3. We have 2. So 3, 2, there's an ordered pair there. We have 1, negative 2. There's going to be another ordered pair here. There's one thing I forgot that's really, really important. I also need to label the horizontal asymptote. Horizontal asymptote is y equals 0. So y equals 0 is really just the x-axis. How do I know it's y equals 0? Well, the degree of the numerator here of this rational function is less than the degree of the denominator, and that will yield a horizontal asymptote of y equals 0. We have the asymptotes in place, and we have ordered pairs. We are now going to graph the 2 branches. Oh, I need to graph one other thing, and that is the hole. 1, 2, 3, 4. Right about there. There's in fact a hole here. We're going to indicate it with a open circle and then draw the rest of the rational function. So it's missing an input and an output value right there, and that's why there's a hole there. So h of x looks like this g of x function, but you got to label the hole. Hole. Circle all your work. You definitely need to have your asymptotes labeled or stated. You definitely need ordered pairs on your graph and labeled. And you should show your factoring. So I want to circle the final answer, which is your graph. And of course the labeling of your asymptotes and the labeling of your ordered pairs. So those are all part of your final answer. Now I'm going to circle the work that's necessary to show, and that is the rest right here. Word problem on direct variation. On a given planet, the weight of an object varies directly with the mass of the object. Suppose that an object whose mass is 7 kilograms weighs 63 newtons. Calculate the mass of another object that weighs 36 newtons. What is direct variation? It's usually a relationship of 2 variables, and if it's directly, if it says varies directly, you just need a proportionality constant, and that proportionality constant is often a decimal in your science classes. Sometimes it's a fraction, but often it is a decimal. Why don't we write that relationship of what does it mean to have direct variation? So why don't we use W in our story here. The W has to the weight of an object, which is called W, varies directly. Varies is going to be substituted with an equal sign. Directly means what? Directly here means there's a proportionality constant. And we call that K, with the mass of the object. So in here we just multiply. We need to multiply by the mass of the object. So let's say we multiply by M. Suppose that an object whose mass is 7 kilograms weighs 63 newtons. So what is that next piece of information? It tells us what we could do to find K. So we're going to substitute now 63 newtons is now equal to K times what? K times 7 kilograms. Not a total surprise. K is 9. We divide the entire sides by 7 because 7 is not 0. And we get K is 9. Now we rewrite our relationship. Our relationship is what? W is equal to 9 times what? 9 times the mass. And now we're ready to answer the last question. Calculate the mass of another object that weighs 63 newtons. So now we just simply put the 36 in here, and then that is now equal to 9 times what? Times M. So what are we going to solve for now? You're going to solve for the mass. I need a line right here. I need a sort of a page break right there. The procedure actually changed there. The mass. The mass is going to be 4. For what? 4 kilograms. You can even state it in a complete sentence. The mass is 4 kilograms. Now, why did I put that page break right here in the middle? And that is because the procedure actually changed. The first part is what? The first part indicated that you're trying to find K. The second part says you established that relationship and then you actually used it to model another scenario, which is the third part. The third part is modeling another scenario. I guess the third part would be this line. Second part is you have to make sure you write the relationship. Once you find the K value, write the relationship. So this is really a 3-step problem. Word problem on inverse variation. This is another scientific relationship. The time it takes to cover the distance between two cities by car varies inversely with the speed of the car. The trip takes 5 hours for a car moving at 72 miles per hour. What is the speed of the car that makes the trip in 9 hours? Let's go back and read this again. The time it takes to cover the distance between two cities by car varies inversely. So we need a letter to substitute for the word time. It makes sense to use T. So right here, I'm going to take that. I'm going to use the letter T. T here stands for the time. Varies inversely. When we get to over here, varies inversely with the speed of the car. Well, remember when we talk about variation, there's got to be a proportionality constant. So we're going to say varies is an equal symbol. Inversely means the proportionality constant is in the numerator, and then the remaining variable, which is the speed of the car, is actually in the denominator. And so when we talk about varies inversely, there is a fraction involved. So that's the first step. First step is actually defining your variables and understanding what does it mean to vary inversely. The second sentence allows us to find the proportionality constant. So the trip takes 5 hours. So I'm going to put a 5 here. For a car moving at 72 miles per hour. And put that over what? Put that over 72 miles per hour. So K is 360. Now, this is very, very important. Now we're going to rewrite our relationship. What do I mean rewrite our relationship? We want T to equal 360, which is the proportionality constant, and then put it over what? Varies inversely to the speed of the car. Now we're ready to answer the third part of this 3-step story problem. Right here, what is the speed of the car that makes the trip in 9 hours? Speed of the car that makes the trip in 9 hours. So we're going to put a 9 here, and that is now equal to 360 over s. Solve for s, multiply both sides by s, and we get that. And so s has to be what? S has to be 4. And of course, it's best to state your answer in a complete sentence. The speed of that car, the speed of a car that makes that trip in 9 hours. God, that should be a 40. Is 40 miles per hour. So as I was writing the complete sentence, I actually caught a mistake. The 4 didn't really make a lot of sense. It didn't sound like common sense. So then that's when I realized, 360 divided by 9 is 40 miles per hour. That sounds a lot more reasonable. Let's circle that as our final answer. Word problem on combined variation. Sometimes the relationship between variables can get a little bit more sophisticated. So there could be a combined variation involved. There could be directly and jointly or inversely. Let's see how this one plays out. Suppose that the amount of time it takes to build a highway varies directly with the length of the highway and inversely with the number of workers. Let's pick on some letters that will help you remember what all these words actually are trying to say. Let's underline this first sentence again. The amount of time, so I'm going to pick on the letter T, varies directly with the length of the highway and inversely with the number of workers. So let's say T varies directly, so there's got to be a proportionality constant with direct variation. Directly with the length of the highway, I'm going to call it capital L, and inversely with the number of workers, which I'm going to call capital W. If it helps, you could translate all this in English. You could say the amount of time is what? T. You could say the length of the highway is L. This is actually a pretty important part about mathematics, is actually translating the English into a mathematical symbol. And the number of workers, so here's the English again. The number of workers is now being translated into a mathematical symbol and is actually called W. Suppose that it takes 150 workers 14 weeks to build 12 miles of highway. 14 weeks. let's just substitute everything. 14 weeks is now equal to K. What's the length of that highway? It says 12 miles. And then put that over what? The number of workers. What was the number of workers? 150. Ah, cool. So of course we could solve for K. K is equal to 14 times 150 all over 12. So K is equal to, let's see, 6 times 150. 150 is divisible by 6. That's 6 quarters. So it's 7 times 25. But what's 7 times 25? 7 times 25, well, it's not quite $2. It's 175. Now let's rewrite our relationship. See if there's anything else to answer. Rewriting our relationship is this. We get T is equal to 175 times L all over W. Now we're ready for the last step. So this is really 3 parts. This little story actually has 3 parts to it. How many miles of highway could 125 workers build in 21 weeks? So we're trying to find L. Let's solve for L. L is going to be what? W times T divided by 175. Let's substitute. What's L? According to that, 125 workers, the time is 21 weeks, and then we simply divide it by 175. So L is equal to 5/7 times 21. What's 21 over 7? That's just 3. So L is 15. Let's answer the question in a complete sentence. About 15 miles can be built by 125 workers in 21 weeks. Ta-da! Recap here. Make sure you realize you are organizing your work. There's actually 3 parts to this problem. The first part is actually be able to find K. So let me put some page breaks on here. So this is right here, the first part. The second part is once you get K, you need to establish your relationship again. And the third part is make sure you answer the new question. The new question here is actually saying find the length of the highway. So this is the third step right here. Here's a problem relating the relationship of a few variables in a business scenario. The word problem on combined variation. Suppose that the number of cars manufactured at an automobile plant varies jointly as the number of workers and the time they work. If 160 workers can produce 32 cars in 2 hours, find the number of cars that 220 workers can produce in 3 hours. Let's look at the very first sentence again. The number of cars manufactured at an automobile plant. Let's translate that to be C. Varies jointly. What does varies jointly mean? Well, you're going to need a proportionality constant. And we need the number of workers. So why don't we call that times W. And the time they work, so times T. So there's your relationship. C is equal to K times W times T. Let's read the second sentence. If 160 workers can produce 32 cars in 2 hours, let's just read the fragment of the second sentence. Let's see what that says. We could plug in a 32 here. We could plug in a K. A W is what? The number of workers, which is 160, by the way. And then the time is what? 2 hours? Ah, we're in good shape. Can we find K? Of course we can. What is K? K is, looks like 1/10. Yeah. Can everybody see that K is 1/10? Divide the entire size by 2, we get 16, and then yeah, it's 1/10. I'm pretty sure. You could write out the details to find out it's 1/10. Now what we're going to do is rewrite our relationship. Our relationship is now what? C is equal to 1/10 times W, which is the number of workers, times the time that it takes, the time that they're spending on producing cars. Find the number of cars that 220 workers can produce in 3 hours. And so we get C is equal to 66. Let's write our answer in a complete sentence. The number of cars produced is 66 if there are what? If there are 220 workers working for 3 hours. And circle.